Hi, and thank you for joining me for the second of two videos looking at straight line graphs. In this one, we are looking at our old friend, the equation y equals mx plus c. We're going to do two things. We're going to work out how to draw a graph given the x coordinates and the equation, and then we're going to move on and look at a graph and figure out how we work out the equation for ourselves. So let's go. A really common question in an exam paper is where you are asked to draw the graph of an equation. And this is a typical example. It says draw the graph y equals 2x plus 1 for values of x from -3 to 3. So first of all, we have to understand what we're being asked to do here. This last part, values of x from -3 to 3, means we are taking a line which is going to have x values along the x-axis of -3 up to +3. What we need to find are the corresponding y coordinates so that we can draw the line. We do this by creating a box which allows us to work out the y values for each of these values of x. Now I'm going to take a look at a couple of slightly different ways of doing this, because I don't always think that what exercise books describe as the easy method is always that. Usually you will see a box like this one. So on the top row we've got x and we've got all the values of x from -3 to 3, which is what is in the question. What we need to do now is substitute each of these values into the equation. So we need to work out the value of y if x were -3, -2, -1 and so on. And this is where it's not necessarily so easy because you have to do a little bit of mental arithmetic. So for example, in our first box here we are given that x is -3. So we put the -3 into the equation. X therefore is -3. So remembering BIDMAS, we have -3 times 2, that is -6, plus the 1, -6 plus 1 is -5. Then we look at the next value of x, that is -2, so again that has to go in the equation there. So now x is -2, so we have 2 times -2, that's -4, plus 1 is -3. And we do this for every value of x. Now, the good thing is that with a straight line graph, you will soon see a pattern forming here. Let me do the next value. X is -1, so put -1 in here. We have 2 times -1, that's -2, plus 1 is -1. Now, if we take a look at these numbers in y, they are actually forming a sequence. -5, -3, -1. They are increasing by 2 each time. And in fact, there is nothing wrong at all with taking advantage of this, because that pattern for a straight line graph will repeat itself all the way along the box. So if we add 2, we get to 1, and then 3, and then 5, and then 7. So you can take a shortcut here by looking at the pattern and repeating it. Some questions will ask you to draw the graph, in which case you don't actually need every single point. To draw a straight line, you might only work out 2 or 3 of them. Some questions might ask you to complete the box, in which case you have to do all of it. Now let me show you a slightly different way if you feel your mental arithmetic is not so strong. This method is very, very similar. I know it won't be good for everyone, but what I'm doing here is breaking down the mental arithmetic. I'm doing this in stages. So you can see across the top I've got the same values of x, and we're going to end up with the same answers for y at the bottom, but I'm going to do it one piece at a time. So the first part of the equation is 2x. So for each of these values we're going to substitute it into the x. So 2 times x becomes 2 times minus 3, therefore minus 6. 2 times minus 2 is minus 4. 2 times minus 1, minus 2. 2 times nothing is nothing. 2 times 1 is 2, and so on to the end of the box. The next part of the equation was the plus 1. So that is what we do. We add 1 in each of these cases. Once we have that, all we have to do is add the red numbers together. We did exactly the same in the first example. We did it in our heads. Here we have it written down. Minus 6 plus 1 is minus 5. Minus 4 plus 1, minus 3, and so on to the end of the box, which gives us the same value. And don't forget, you can still take advantage of the pattern here. These are two slightly different ways of achieving the same end. The first one uses mental arithmetic. The second one puts it down on paper for you to be able to see. Now let's move on to actually plotting the graph. So now we have sets of coordinates for every value of x. We found the corresponding value of y. So the first one is minus 3, minus 5, and the first coordinate is therefore plotted here. The second one, minus 2, minus 3, is going to go here. 0, 1. We've got 1, 3. We have 2, 5. And in fact, the last one won't quite fit on my graph paper. It's at 3, 7. Once we have all the points on the graph, we can see visually that what we are drawing is indeed the straight line. If any of the points are not on the line, you need to check your figures. They'll probably be wrong. If you are confident in your numbers, you actually only have to plot maybe 3 of these to give you the position of the line, and that will be adequate in an exam question. I'm going to use this page for a couple of things. First, we're going to have a practice by drawing another straight line from a very similar question. But once we've done that, we're then going to tackle the second problem that you might have to face, and that is where you are given a line and you have to do the opposite and work out what its equation is. So let's start with the bit that we're familiar with first. So we've got y equals 3x minus 2 for the values of x from minus 3 to 4. So here we've got the box with all the values of x from minus 3 to 4. Let's start filling in the bottom box. So y is 3x minus 2. So first of all, 3x, that's 3 times minus 3. That is minus 9. Minus 2 is minus 11. The second box, 3x is 3 times minus 2. That's minus 6. Minus another 2 is minus 8. The next box, 3 times minus 1 is minus 3. Minus the 2 is minus 5. At this point I'm getting bored and I can see the pattern. This time it is going up in threes. So it's going to be minus 2. It's going to be 1. Then 4. Then 7. And then 10. And let's just check the last one to make sure we've got that right. 3 times 4 is 12. Take away 2 is 10. So there we go. We have our coordinates. Now let's have a go at drawing our line. We have our values. So our first set of coordinates are minus 3, minus 11. So minus 3, minus 11 is almost off the edge of my graph here. Minus 2, minus 8. Minus 2 along, minus 8 down gives us a point there. We have minus 1, minus 5 here. We then have 0, minus 2. We have 1, 1, 2, 4. And we finish with 3, 7, and 4, 10. And of course the test is to find out whether in fact we do indeed have a straight line. And if you take a ruler, yes we do, all the points are on the line. So that is the first part of our question. Once again, we've created a line from a set of figures. What I want to do now is remove those figures and have a look at the line itself. So I've now removed all the numbers and the equation because I want to do things in reverse. We need to be able to look at a straight line such as this one and figure out what its equation is. It's not so difficult as it sounds. The equation that's going to help us to do this is the one at the top here. y equals mx plus c. This one is a really useful one to memorize. This is the standard format for straight line graphs. So the ones that we've been doing have been things like y equals 2x plus 3, y equals 4x minus 1. So m and c are the numbers that you are given in the equation. We need to understand what these two numbers, the m and the c, mean. Let's have a look at m first. The m tells us the gradient of the line. In other words, how steep it is. So if the gradient has a high value, the line will be a steeper line, a low gradient, and less of an incline. I did look at how to find the gradient in the first part of my straight line graph videos, but we are going to do it again here to work out the equation of this line. C is the simple one. C tells us where the line crosses the y-axis. It is called the intercept. Unless a line is actually vertical, which we did again look at in my first video, then it will at some point cross the y-axis, and C simply tells us where. So let's have a look at this particular line and let's see if we can work out the values of m and c, and in that way give us the equation of the line. First of all, let's take the gradient. The way to calculate this is to pick 2 points on the line, and it doesn't matter which 2 points we pick. I'm going to select these two and highlight them in red. The next thing we do is we connect the two lines, and we do this by creating a right angled triangle like this on the bottom side of the line here. I did say it doesn't matter which 2 points you pick. It is useful if they are just quite simple, straightforward numbers, because what we're going to do is measure the distance that this line has travelled from the bottom red cross to the top one in terms of how far it has gone along the x-axis and also how far on the y. In other words, we are measuring the two lines of the triangle here. So in the x direction here, it has gone from 2 to 4, therefore it has gone up 2. At the same time, it has travelled up the y-axis and it has gone from 4 up to 10. So it's actually travelled up 6. Now we have a little formula to work out the gradient, and the formula is the distance that it has travelled on the y-axis divided by the distance that it has travelled on the x-axis. In other words, y divided by x, in this case 6 divided by 2, the gradient is therefore 3. So in our equation for this particular line, we have a gradient of 3. The gradient is the m, so the m is therefore 3. Now let's have a look at the intercept, and as I said before, it is simply the point at which our line crosses the y-axis. In this case, it is here at -2, therefore that is C. So the equation of the line, which we knew earlier before we drew it, is y equals 3x minus 2. Let's quickly have a look at another line. So here's a line, and looking at it, we can see already that it's going to have a lower gradient. It is not such a steep line. So it is going to follow the pattern y equals mx plus c. Therefore, again, I've written y and x in there. We need to find the m and the c. Let's find 2 points on this line to help us find the gradient. Well, here I'll take a point there, and I'll pick a point here. Now, again, I'm going to create the triangle. So I need a line that is going to go down from the top to the line here and one across. Now, just being careful that we are using a slightly different scale along the x and the y axis. Let's have a look at the travel of the line. On the x-axis, it has gone from 4 up to 6. So it has gone up 2. On the y-axis, it has gone from 3 up to 4. it has only travelled up 1. So again, using y divided by x, we actually end up with 1 divided by 2, a half. And that's perfectly acceptable. We can have a gradient of a half. Now let's fill in the c, which is the intercept, the point at which the line crosses the y-axis. In this case, it is here, which is at +1, so we add +1. Y equals half x plus 1. And for our final example, I want to have a look at the line that is sloping in the opposite direction. Let's do exactly the same as we've done for the last two. I've got y equals x. I need to put in the gradient and the intercept. I'll do the intercept first this time, plus c. It's on the y-axis. It's at 2, therefore it's going to be +2. Now, let's have a look at the gradient. I'm going to do exactly the same again and pick 2 points. As I said before, they can be anywhere on the line, so I will have this one and I will go with this point here. So I'm going to draw the triangle. It looks a little bit different this time. It's on the other side of the line. And we're going to once again look at the movement on the x and the y. Now, this time, the x is very much the same. The line has travelled from x equals 2 to x equals 4. So it has moved along in this direction by 2. However, the y is actually, reading from left to right, going downhill. It has travelled from -2 to -6. It has actually gone downhill. It has travelled -4. This time, if we do y over x, we have -4 divided by 2, which equals -2. The gradient, because this line is sloping downhill from left to right, has a negative value. The calculations are just the same, you just need to be aware of the minus number because the line is travelling downhill. As it goes up the x-axis, it is travelling down the y. So the actual gradient that goes into our equation is a -2. And finally, just be aware of the situation where the examiner might want to make it appear a little more tricky, and they might just juggle round with the equation. So they might ask you to find the straight line of something like 3x plus y equals 5. This does not appear to be in the same format as our original y equals mx plus c. There are a couple of things you can do. You can draw your box which gives you all the values of x, put them into here and work out what the y would be for it to make up to 5. Or you could actually rearrange the formula. You want to take y on its own, so if we take the 3x and move it to the other side of the formula, it becomes -3x plus 5. We therefore have an equation now which is in the same format as our original. And that is straight line graphs covered. A lot to take in there. Have another look, please, if you want to make sure you've got all the points. Please do subscribe to my channel if you found this useful, and hit the subscription button so that any new videos will come straight to you. I hope to see you again. Thank you.